I would like to invite Dr. RP Sharma to share his views. And so please, Dr. Sharma, please. So thank you very much. You can say it.
Well, good evening, all of you. And thank you, Dr. Rajiv Vashne, for this invitation. In fact, I'm also thankful to you to help me keeping myself up to date in this area. Because I have attended quite a few meetings here, and the way this area is progressing, I'm not working effectively in that area, but at least I know what all is happening around. And for that, I would like to thank you for that. I am a farmer. I think many people would start doubting on my farm and interact with the farmers. And when I do that, many times I have the quotation from Eisenhower when he wrote that farming looks mighty easy when your plow is a pencil and you are 1,000 miles away from your cornfield. Many times in science, when we discuss, we get lost into the academics, and which we should be, but ultimately we must also be very aware what are ultimately our goals. And that's where the farmers would need. When you talk to farmers, you will find that their demands are very clear. Farmers in their own right, they are entrepreneurs. Their survival depends on their whatever little earning they do from their agriculture. And therefore, they would not really be entering into the academics, but they would like to have the results. One of the farmers asked me that we would like to have many of these. Is it like giving the example of BT cotton? Is it possible to put many of these traits in the seed itself so that we don't have to really spend money separately on pesticides and insecticides, not only from the environment angle, but also from the economic angle? With time, demand of the farming community is going to increase. And therefore, most of our breeding program must be addressing to what is needed by them. If plant breeding, as in the morning someone referred to, is an art, I think many people would not agree because the kind of scientific components which have been put here is a hard science. So, we started in plant breeding initially the selections. And ladies certainly has contributed a lot because of the farming for women. They have the one they started collecting the new varieties, new variations, and new varieties. I was in this discussion, this planning session, got a mixed feeling. Plant breeding cannot be taken in isolation from genomics. We must strengthen, we must combine them together. Plant breeding is plant breeding, irrespective of the tool which you are using. Depending upon your capabilities, the feasibility, the resources available, choose the best tool which you would like to apply. And that's where application of advanced genomics in crop improvement is very timely. Tools are not available. Let me give my own example, the way I got involved. I used to teach somewhere in 1992, the course of eukaryotic molecular genetics in IRI. And some of the students might be here from that time. In the evening, from 6 to 8, we got the tape from Timesley to Chan Makuch. So in the evening, after the lecture, we used to play those tapes every day almost. And each of that in the train, in the component of that protocols that we used to discuss, used to see discussion. And I think the students used to enjoy it. They would not leave the class, even if it is 8 o'clock. From there, we started doing DNA fingerprinting. Dr. Mahapatra has played a very great role in it, and we should acknowledge it. Then we moved forward and we started doing trait tagging, and we tagged the white rust resistance in Brassica. Followed by, we got a project from Government of India on genome sequencing in rice, and IRISE played a great role. And subsequently, we got deeply involved in molecular breeding and character tagging. Many of the varieties, now at least 3-4 varieties in IRI, has been developed using molecular markers. But I still feel that plant breeders and I will consider the technology developers and technology users. I will not use the word of plant breeders. Plant breeders are technology users, and molecular biologists are technology developers. How do we bring them together? The kind of discussion which took place, I find that there is a deep divide. Those who are talking about conventional plant breeding, in my opinion, this word of conventional or advanced should be removed. We are breeders. And we must select what we want to do. Goal ultimately is the product. Those people who think that they are not getting enough funding, you start writing joint projects. Then you will defend. You will defend the requirement. Because it will not be, no one would say that this is a project for conventional breeding, or this is a project for this. We will say this is a project for such and such trait development, which is needed. So I think, in my opinion, as a policy decision also, two things can happen. One is at the teaching level, strengthen the teaching of conventional and conventional breeding. We are quite strong, but integrate the molecular breeding in your total breeding approach. Number one, and number two, start writing joint projects. Wherever joint projects are there, then you have to. You do not really be saying that they were biased. They have removed the projects. They have not given the funding for the conventional breeders. So I think that would be, in my opinion, that would be an approach which one would like to follow. I was reading a review recently by Dr. Hu and the other name, and David Edward from Western University, Australia. I will suggest all the breeders, those who are working in advanced genomics, they would know certainly, but all the breeders must go through. The title is Advances in Integrating Genomics and Bioinformatics in the Plant Breeding Pipeline. It's a very good summary of what has happened, what needs to be done, how we are going to integrate the genomics in conventional plant breeding for achieving the desired goals. In fact, the amount of work which in this review, which has been presented there, you will be amazed. For example, I was saying that someone asked the question of yield. Please, are the genes involved in yield? In this paper, they say they have identified 5 groups of yield contributing genes in wheat, and using 195 molecular markers, 37 QTL related nitrogen fixing genes. Things are advancing very fast. We have to choose. And I will conclude by giving my own suggestions how and where we should be spending our money. For example, yield. is a quantitative traits. There are a large number of components whose contribution ultimately makes the yield. Are we, as a molecular markers, molecular breeders, have we started identifying the genes involved in yield? Have we started also reconstructing the genotype with the QTLs which we would like to assemble together? In other words, can we reconstruct the new genotypes where the yield component genes involved, whether the yield we are taking here as a character, but this character is a complex character. There are a number of other genes which are involved, which need to be separately tagged and then reshuffled. We also, I would like, where you should give emphasis, genomic definition of heterosis. The yield is one is conventional recombinance breeding. You can increase. The other is you can exploit the heterosis. There are quite a few projects and quite few crores of rupees which were given in QTR identification of heterosis. But I don't think from those projects anything new emerged. Mostly, in my opinion, the material which they started comparing two different parents showing heterosis. There was enough control with what we are going to compare. How we are going to identify QTLs? The best approach would be, and wherever it is feasible, follow the double haploid group. Take the standard parents which are heterotic, double the double haploids, look from them which are showing heterosis, and then start comparing at the genomic level which are the regions which basically are responsible for heterosis. These are in my opinion, that certainly will give you. Start also subjecting now these traits which show negative correlations. In plants, in almost all the plants, if you want to increase seed size, your seed number goes down. Why? What is the definition of genetic definition of this particular negative correlation? These are the burning questions which need to get us through marker assisted breeding. Then many more things will come. Climate resilient crops and genotypes. Already there is a demand. Why I am saying this? In variety development, there is going to be a continuous struggle between the breeders, and that any conventional breeder they know there is continuous struggle between the breeders and the demand, which they were having. I give two examples. C2C238, the variety which has revolutionized sugarcane production in whole of northern India. This time, the variety, you can have a sugarcane about 16 to 20 feet high. In northern India, you cannot expect more than 9.5 to 10% increase recovery of sugar. This variety is the one which can give up to 12%, 11 to 12% in between somewhere the sugar recovery, and a very tall plant. This year, because of the inclement weather, continuous rain, two things have happened. One, the foliate part of the plant is reduced. I think this characteristic, and when I talk to the farmer, they say, this variety is very good, but you don't get the fodder. Invariably, the farmers, they get the sugarcane cut and processed in lieu of the fodder which they get for their animals. Now the farmers are facing, because those people are not coming for harvesting, they have to pay more money. One has to take. Second, and which is again very good, 1509 is a rice, basmati rice. Very good, excellent rice. Almost all of it is exported. The farmers, they are growing it only for commercial purposes, not for their own consumption. Because in milling, there is quite a bit of breakage. So these are the kind of things which, when you want to do genomic selections and those kinds of things, I don't think certainly these kinds of traits you will be looking for. They will get eliminated. They will not be selected. So you have to be very, very aware what exactly is the basic requirement, which are the best parents, how to process them, what are the tests which we want to do it. we have not yet, I think many times I give example, there is a lady from cement. Can we take most of the breeders, can we take the advantage of the protocols which civils have developed? Variety parent selection and the utilization breeding program is done by a group of team of multidiscipline. In this country, most of her breeding is biparental crossing and selected by breeders without any basic information available with him. We have to learn quite a bit. Our conventional breeding itself, we have to perfect. Over and above it, we have to integrate the advanced genomics. The future is bright, but will require very hard work. Thank you very much.